Hi guys, this is Lauren from Tata Robotics. Today I'm going to be showing you how to build the Serie 1780 test stand. This is the 75 kgf model of the stand. It's currently the biggest stand we offer. It can measure 75 kilograms of thrust as well as 48 newton meters of torque. In addition to showing you how to set up the stand, I'm also going to show you how to install the motor and propeller, and then we'll run some propulsion tests. So let's get started. Starting from the ground up, the first thing we'll do is assemble the ground structure. This is done in several steps, starting with the preparation of different frame components. Here I'm joining gusset brackets and an L bracket to frame pieces that will hold together the two main ground rails. In total, we will need 2 of these assemblies, which we'll then attach to the 4-foot T-slotted double beams. Now we slide these pieces onto our 4-foot beams, and we can give them a little bit of a tighten, but at the end of the construction we're going to use a torque wrench to tighten them to a specified amount. I'm now attaching more gusset brackets to the frame pieces that will hold together the main vertical frame. We then take the frame pieces, 4-foot T-slotted single beams, and slide the smaller frame pieces just between them. This part can take a little bit of adjusting to get the spacing right, so again, we won't fully tighten them right away. Down at the other end, I'll attach more gusset brackets to the end of the 4-foot beams to help stabilize them on the ground rails. And you guessed it, we then slide on more stabilizing frame pieces to connect the stand to the rails and keep it upright. We will attach the socket head screw and nut to each of the aluminum rods before attaching them to the vertical part of the stand. They slide right on each side. Some more ground support. Things really start to come together as we slide the vertical unit on the ground rails, fastening them in a number of locations, and attaching the other end of the aluminum rods to the ground rail. It's important to not work alone during this process, as there are many parts and pieces to keep track of, and many tasks are made a lot easier by having at least 2 people. Adding more L brackets to the ground rails gives the option of either bolting the stand to the ground or other ground fixture you may have in your lab. We then go around and tighten all of the screws with a torque wrench. A table in the Serie 1780 manual tells you exactly what torque you need for each type of screw, so you can use that as a reference. Now getting to the good stuff, I'm building the rectangular blocks here, which are used to attach the motor mounting plate and the LMU to the test stand. So now we have both of our fully assembled rectangular blocks. You'll notice that I didn't fully screw in the screws, I left a little bit of space here, and that's because we need to slide them into the slots right there. So now that we have the rectangular block set up, our next step is to install the load measurement unit. Now the LMU has 3 load cells on the back, and these measure the forces of thrust and torque. So what we're going to do is we're going to install this on the rectangular blocks, just like that, but before we do, we're going to install some standoffs around the edges here, and those ensure there's sufficient space between the load measurement unit and the motor mounting plate. So let's start with that. Now that we have the LMU set up, the next logical step is to install the motor mounting plate. That said, in terms of spacing, it's actually easier if we mount the motor on the plate before attaching it to the stand. So first, we'll attach the motor, and then we'll get it all set up on the LMU. Now that our motor and propeller are installed, our next step is to set up our power components. So we'll hook up our power and control console, our main board, as well as our ESC. The power and control console, as well as the ESC, connect to the vertical part of the stand. The positive wire of the ESC goes through the Hall sensor on the power and control console to measure current, then connects to the power source. The power source may be a LiPo battery or a power supply, and we use a 30 kilowatt power supply from MCB Electronics to power our tests. We connect the motor to the ESC, then the cables from the power and control console are connected to the power sensor and ESC control ports on the main board. This is a good time to connect the cables from the load measurement unit as well, which connect to the optical RPM probe and force sensor ports. The load measurement unit is factory calibrated before it is shipped out. The USB cord attaches the main board to your computer and the software, and the power adapter to a power outlet. The optical RPM probe measures your motor's rotation speed by sensing a piece of reflective tape placed on the motor. A spacer and screw are selected based on your motor's height, and the probe is installed between 2 to 5 millimeters away from the motor. The probe's cable is then attached to the load measurement unit. Now that our system is all set up, it's time to run some propulsion tests. So the first thing we have to do is download the RC Benchmarks software, which we can do on the Tidal Robotics website. So we'll head on over to Knowledge Center, then Software Download. And we'll download the most recent version. And quickly go through the installation instructions. Then we'll head on over to our desktop where we'll find the program, open it up, and then accept the safety agreement so we can get started. The first thing we'll do is head on over to Setup, where we'll put in our working directory. Here it's set up as documents, which is just fine. And then we'll enter in the number of pieces of reflective tape that we put on our motor, so our optical sensor knows how to measure our RPM. Next we'll head on over to Welcome and connect our test stand, just like that. And you'll see the data starts rolling in, and you can select which real-time plots you want to see. The next thing we'll do is tear our load cells and current. And then we'll head over to the Manual Control tab, where we can run some manual tests. All we have to do is click on our ESC to activate it, and then pull up our slider to increase the throttle. Next we can run an automated test, which we can set up using our scripting capability in the Automatic Control tab. We'll go ahead and clone the script for a ramp test. We'll start by assigning a name to the file, and then we'll head over and start editing our script. So in this case, we'll just change the maximum throttle input value to 1600, and otherwise we won't change any of the timings of the test. We'll head on over to Run and then Start, and our script will start rolling. Once our test is completed, we can head on over to the folder that we set as our working directory, and our files will be waiting for us there. So we can click to open one of those. And here we have all our wonderful data from our tests. We look at torque, thrust, RPM, electrical power, mechanical power, our motor propeller efficiency, and overall efficiency. And as you can see, we have lots of wonderful data points here. So today we've covered how to build the Serie 1780 test stand, how to add your motor and propeller, as well as how to run automated and manual propulsion tests. If you have any more questions about the equipment, you can send us an email to sales@tidalrobotics.com, or you can leave us a question in the comments. Thanks so much for watching.